Hello everyone. In our previous lecture, we have learned the concepts of intercept made by line on x and y axis, also inclination of a line, slope of a line, and the angle between two lines. In this lecture, we will solve some examples based on those concepts. Let us see example number 1. Find the slope of a line which passes through the points A. For instance, let us take A is 2 minus 1 and B is 4, 3. And second case or second part of this example, in which point C is minus 2, 3 and B is 5, 7. We know the formula for slope. Since slope n is equal to y2 minus y1 upon x2 minus x1 or y1 minus y2 upon x1 minus x2 under condition that is x1 is not equal to x2. Here also x1 is 2, x2 is 4, here minus 2 and 5, so x1 and x2 are different, so we can use formula this. Therefore here slope of line AB that is equal, here this point A, we will consider this point A as x1 y1, or we can write it also before using this formula. We can write here A is 2 minus 1, consider it as x1 y1, and B is 4, 3, that is x2 y2. Now we can use the values of x1 and y1, x2 equal to 4 and y2 equal to 3 in this formula. Therefore slope of AB, slope of line AB or segment AB is equal to, using formula, is y1 minus y2 upon x1 minus x2 is equal to, our y1 is minus 1, y2 is 3, so minus 1 minus 3 whole divided by x1 is 2, x2 is 4, so it is equal to minus 1 minus 3 minus 4 upon 2 minus 4 is minus 2, this minus minus becomes plus, and the answer will be 4 by 2, that is 2. So here the slope of line AB is equal to 2. Let us see second one. The point C is minus 2, 3, so x1 equal to minus 2 and y1 equal to 3. Point B is 5, 7, so x2 equal to 5 and y2 equal to 7. We can substitute these values here. So the slope of line CD becomes y1 minus y2, or instead of that we can use y2 minus y1 upon x2 minus x1. Here y1 is 3, y2 is 7, so 3 minus 7 upon x1 is minus 2 and x2 is 5, so 2 minus 5 and is equal to 3 minus 7 is minus 4 upon minus 2 minus 5 is minus 7, both are negative numbers, so their division is positive and is equal to 4 by 7. So the slope of line CD is 4 by 7. Orally also we can find it. 7 minus 3, that is 4, and 5 minus 2, that is plus 2, 7. So 4 by 7. That is the way to find the slope of line which passes through the given 2 points. Let us see second type of example. Example number 2. If x and y intercepts of a line L are 2 and 3 given, then find the slope of line. Then find the slope of line L. Let us see how to find the slope of this line L. Here, in this case, if you draw the figure of this line, then line L makes slope of 2 on x-axis. This slope, intercept 2 is on x-axis and intercept 3 on y-axis. So this is the intercept 2 on x-axis and positive 3 plus 3, so it on positive y-axis. So suppose this is the intercept 3 on y-axis. If the distance of this point from the origin is 2, obviously the coordinates of this point A will be 2, 0. And if this point, certain point B, is at a distance of 3, then its coordinates will be 0, 3. So, as these intercepts are given, from these two intercepts we can determine the coordinates of these 2 points which lie on x-axis and y-axis. So again, we know these 2 points now. We can draw line passing through these 2 points, and the question is asked to find the slope of this line L. So again, we know these 2 points. So what to write here? Since line L makes intercepts on x and y axis, makes intercepts of 2 and 3 on x and y axis respectively. Therefore, the points on x and y axis where the line cuts are 2, 0, are A 2, 0 and B 0, 3 respectively. Therefore, the slope of line L is equal to, by using formula, that y1 minus y2 is equal to y1 is 2, y1 is 0, here y1 is 0 and y2 is 3, whole divided by x1 is 2 and here x1 is 0. So it is equal to minus 3 by 2. So slope of the given line which cuts intercepts of 2 and 3 on x and y axis respectively, its slope is equal to -3y. We can easily find this slope from this figure also, because here slope is y intercept is 3, x intercept is 2, taking the ratio of these two with negative sign. So it is -3y. Why? Because line has negative slope. Now let us see next example. Example number 3. Find the slope of line whose inclination is 30 degree. In this example, the inclination of line is given. What is meant by inclination? Here, the inclination of line is 30 degree. Therefore, theta is equal to 30. We know that slope of line is equal to tan theta. Slope of line is equal to tan theta. Therefore, n is equal to tan 30, and tan 30 is equal to 1 upon root 3. So the slope of line whose inclination is 30 is equal to 1 upon root 3. So this is the slope of given line in this example number 3. So it's a very simple example. Let us solve one more. Example number 4. If a line makes intercepts 3 and 3 on the coordinate axis, then find its inclination. If a line makes the intercepts 3 and 3 on coordinate axis, then find its inclination. In this case, intercepts are given and the question is asked to find its inclination, not the slope. So let us try to solve, draw the figure corresponding to this given information. Here the intercepts are 3, 3. So on x axis the intercept is 3. On y axis the intercept is also 3. So these are the two intercepts made by this line, and we have to find the inclination. So let us try to draw the line first, passing through these two given points. We have to find the inclination of this line. Consider the inclination of this line will be theta. Let L be a line which makes intercepts 3 and 3 on coordinate axis. Obviously, by knowing these two intercepts, we can find the slope of line. Here the coordinates of point A will be obviously 3, 0, where the line cuts x-axis. This line L cuts y-axis at this point, so its coordinates are 0, 3. So we know these 2 points on this which are lying on this line, so we can find the slope of that line. Therefore, the points or the line cuts, therefore the line cuts x-axis at, directly we can write x-axis at 3, 0 and y-axis at 0. So from this we can find the slope of the line. Therefore, slope of line L is equal, it is y2 minus y1, and write formula y2 minus y1 upon x2 minus x1, that is equal to 3 minus 0 upon 0 minus 3. So it is equal to 3 upon minus 3, that is equal to minus 1. But what is slope of line? It is nothing but tan theta. If, or consider, if theta is the inclination of line, then slope of line is nothing but tan theta. So here we have tan theta is equal to, this slope of the line is equal to minus 1 and slope of the line is equal to tan theta. So tan theta is equal to minus 1. So slope of the line tan theta is equal to minus 1, and from this equation, if tan theta is equal to minus 1, when theta is equal to minus 1, if theta is equal to 135. So we can write here if theta is equal to 135, since 135, then tan theta is equal to minus 1. Therefore, or in other way we can write, since tan of 135 is equal to minus 1, therefore theta is equal to 135 degrees, and that is nothing but the inclination of the line. So whenever a line makes two intercepts on x and y axis which are equal, then the inclination of line will be 135 degree. Okay, let us see next example. Without using Pythagoras theorem, example number 5. Without using Pythagoras theorem, show that the points A 4 4, B 3 5, and C -1 are the vertices of a right angle triangle. We don't know which angle is right angle, so there is no need to draw the figure. Just find the slopes of two lines or slopes of all the sides of triangle. Here A is 4 4, we consider it as x1 y1. B, that is x2 y2, and is equal to 3 5. And third point C is given -1 and is nothing but x3 y2. Now, since slope of line, if 2 points are given, then it is equal to y1 minus y2 upon x1 minus x2. Therefore, using this formula, we can find slope of line, slope of side AB or line AB. Same. Slope of side AB means we will take these 2 points and find slope from these 2 points. Here, difference in y, that is 5 minus 4, upon difference in x, that is 3 minus 4. Take the corresponding differences. Don't reverse the way. Here 5 minus 4, that is 1. 3 minus 4 is -1, so it is equal to -4. Similarly, slope of side BC, it is equal to BC. Take these 2 points. Here difference in y coordinates is 5 minus plus 1. 5 minus of -1 upon 3 minus of -1. So it is equal to 6 upon 4, that is equal to 3 by 2. And last, slope of side AC. Here is A, here is C. Take the difference in y coordinates, that is 4 minus 1 upon 4 minus 1. So it is equal to 5. This is also equal to 5, and the resultant slope of side AC is 1. If you observe the slopes, then if you take the product of slopes of lines AB and AC, then their product will be -1. So here, slope of line or side AB into slope of side AC is equal to -1 into 1, that is -1. Here the sides AB and AC, their product of slopes is -1. It means AB is perpendicular to AC, and as AB is perpendicular to AC, obviously, therefore triangle ABC is a right angled triangle at which one is common? A. So it is right angle triangle at A, where A is right angle. So this is the way to show that these 3 points are the vertices of right angle triangle. In this case, or in this example, we have used the same formula for slope for finding slope of side AB. BC and AC. By observation, you can conclude the product whether product of which two numbers is -1. Just write those two numbers or take those two sides and write it equal to -1. And from that, conclude the result. Let us see next example. Find the value of k for which the points A k minus 1, point B 2 1 and C 4 5 are collinear. In this example, these 3 points A, B, C are given as collinear points. If 3 points A, B, C are collinear, obviously slope of AB, line AB or segment AB is equal to slope of segment BC. It is same as slope of segment AC because all these 3 points are lying on same line. As these 3 points A, B, C are lying on same line, so slope of AB, slope of BC and slope of AC is same, or that slope is nothing but the slope of line L. So we will take that condition here, given condition. Here let A k minus 1 is equivalent to x1 y1, B 2 1 is nothing but x2 y2, and C 4 5 is equal to x3 y2. So from these 3 points, let us find the slopes of ABC and find slopes of any two segments. As points A, B and C are collinear, therefore slope of AB is equal to slope of BC. Therefore, what is slope of AB? It can be obtained by taking the difference between y coordinates upon difference between x coordinates. Here, from AB, the slope of AB is minus 1 upon k minus 2 and is equal. Slope of BC, take the difference between y coordinates. If you take 5 minus 1, take the same sequence 4 minus 2 upon 4 minus 2. Just simplify this. This will be minus 2 upon k minus 2 and is equal to 4 upon 2, that is equal to 2. So minus 2 upon k minus 2 is equal to 2. So this gives us minus 2 equal to, multiplying this side by 2, k minus 2 into 2, that is 2k minus 4. 2k minus 4. Take this 2k or take this minus 4 to the left, it becomes plus 4 minus 2 equal to 2k. This is equal to 2 equal to 2k, and therefore k is equal to 1. So this is the value of unknown k. Is it okay? In this example, this A, B, C, 3 points are given collinear. In these 3 points, one coordinate is unknown that we have to find. For that, as ABC are collinear, slope of AB is equal to slope of BC. Use the formula for slope and just simplify, you will get the unknown K. Okay, let us move towards the next type of example. Example number 7. Find the acute angle between the two intersecting lines which pass through the points having slopes 2 and -3. Let us see simple example. Here the slopes of two lines are given, 2 and -3, and we have to find the acute angle between these two lines. Here, let M1 and M2 be the slopes of two lines. Therefore, from given M1 equal to 2 and M2 equal to -3. If theta is the acute angle between these two lines, initially what to do? Here numbers are given which are slopes of two lines, 2 and -3. For that, two slopes take their general symbols M1 and M2. Here theta is the acute angle between these two lines. If then you know the formula, that is tan theta is equal to, what is that formula? It is nothing but the modulus of M1 minus M2 upon 1 plus M1 M2. Obviously, for this formula, the condition is M1 M2 should not be equal to -1. And here, the product of two slopes M1 and M2 is 2 into -3, that is -6. So it is not equal to -1. Therefore, this is equal to, put the values, M1 is 2, M2 is minus of -3, 1 plus 2 into -3. So it is equal to 2 minus -3, that is 5, upon this is 1 minus 6, that is -5. 5 upon 5 is 1, so it is equal to mod of -1, and it is equal to 1. So here tan theta is equal to 1. Therefore, theta is equal to tan inverse of 1, or we can easily realize that here tan of 45 is equal to 1, so theta is equal to 45. Therefore, theta is equal to 45 degree or 5/4 radian. So this is the way to find acute angle between two lines having slopes 2 and -3. This one is very simple. Just use this formula finding slope, finding angle between given two intersecting lines. Next one, example number 8. Find the acute angle between x-axis and a line joining points A, that is 3 minus 1, and B, that is 4 minus 1. One line is given as x-axis and second line is line AB, and in this case we have to find the acute angle between these two lines. So initially we will find the slopes of these two lines, as one of the line is x-axis, as one of the two lines is x-axis. Therefore slope of x-axis is equal to, suppose m1, obviously it is equal to 0. So this is the first point, m1 equal to 0, and the slope of line AB is equal to, suppose, m2, and it is equal to difference between y coordinates upon difference between x coordinates. Here y coordinates are nothing but this minus 2 minus 1, or minus 1 plus of minus 2 upon 3 minus of 4. So it is equal to minus 1 minus 2 is minus 3, and here is minus 1. Minus 3 upon minus 1 is plus 3. So this is the slope of line AB, where this m2 is equal to 3. So we have here m1 equal to 0 and m2 equal to 3. Let, as usual, again consider theta. Let theta be the acute angle between given two lines. Therefore tan theta is equal to modulus of m1 minus m2 upon 1 plus m1 m. Now here m1 is 0, so mod of 0 minus m2 is 3 whole divided by 1 plus 0 into 3. So it is equal to minus 3, modulus of minus 3 upon 1. So it is equal to mod of minus 3, and this is again equal to 3. So here tan theta is equal to 3, and the question is asked to find the acute angle. Tan theta is not acute angle, it is the tangent ratio of acute angle. Therefore theta is equal to tan inverse of 3. There is no particular value for tan theta that is equal to 3. There is no particular angle whose tangent ratio is equal to 3. So just keep this theta in terms of tan inverse, theta equal to tan inverse of 3. So this is the way of solving such type of examples. Whenever one x-axis is given and a line joining two points is given, at that time we can find acute angle between those two lines using the same formula. Let us move towards example number 9, which is different from these other examples, because in all these 8 examples they have taken certain numbers which are known numbers, but let us solve the next 2 examples in which unknowns are given. A line passes through the points, example number 9. A line passes through the points A x1 y1 and B hk. These two A and B, these 2 points are given here. If the slope of the line is n, if the slope of line AB is n, then prove that k minus y1 is equal to m into h minus x1, where m is the slope of line, where m is the slope of this line. Then find this equation or prove that this equation is true. Let us try to draw first figure for this example. Here this line passes through points A and B. Here the 2 points are like A, that is x1 y1, and second point B is hk, and the slope of this line is given n. Slope of the line is n. So as on this line we know these 2 points, from these 2 points we can find the slope of line and it is given n. So equate 2 slopes, one given slope and second that you will find from A and B. So here slope of line AB is equal to n, that is given. Also A is x1 y1 and B is hk. Therefore slope of line AB from these 2 points is nothing but difference in y coordinates, that is k minus y1, upon difference in x coordinates, that is h minus x1. Now this is the first way in which slope of line is given, and this is the second way or second slope of the same line AB that we have found using formula. So equate these 2 slopes, because these 2 slopes are the slopes of same line AB. Therefore k minus y1 means from equation 1 and 2, k minus y1 upon h minus x1 is equal to m. Just take this denominator to the right, it gives us k minus y1, that is equal to m in bracket h minus x1, and that is the required equation. This. So this one is also very much easy. Let us try to solve the last example, which is very much different from again these examples. Example number 10. I think all these examples depend on the formula of slope and angle between 2 lines. Let us see example number 10. If the points A, B, C lie on a line, if the points A, that is H0, B, that is 0P, and the third point C is AB, lie on a line, then show that A upon K plus B upon H equal to 1. A upon H plus B upon K is equal to 1. Again, here 3 points A, B and C lie on a line. Lie on a line means they are collinear points. And if 3 points are collinear, once again let us see the figure related to this. In this case, here point A is H0, point B is 0K, and third point C is AB. So these 3 points are collinear. So if we find the slope using these 2 points A and B, we get slope of AB, that is nothing but the slope of line N. If you use these 2 points, then you get slope of BC, and the slope of BC is nothing but the slope of line N. So slope of AB and slope of BC, obviously those are equal slopes. So let us use that way. Here A is H0. You can consider this as x1, y1. B is 0K, which are nothing but x2, y2. And C is AB, which is same as x3, y. Therefore, here points A, B, C are collinear because they are lying on same line. Therefore, slope of AB is equal to slope of BC. Slope of AB is equal to slope of BC, or you can take slope of AC equal to slope of BC. Anyway, let us slope of AB, A and B are x1 and x2, y2. Therefore, those slopes are y1 minus y2 upon x1 minus x2. Slopes of BC are x2, y2 and x3, y3. So the slopes are y3 minus y2 upon x3 minus x2. Let us put these values. Therefore, get y1 minus y2, that is y1 is 0 and y2 is k. So 0 minus k upon h minus 0, and is equal to y3 minus y2. Y3 is b and y2 is k. So b minus k upon a minus 0. This gives us equation minus k upon h, and to the right we get b minus k upon a. Okay, let us take the cross multiplications so that we get here minus ak, and here multiplying we get bh minus ah. BH minus KH. Let us change the sides so that here we get AK, or change the signs of all terms. So plus, minus and plus. In next step we can change signs. Take this BH to the left so that here we get AK plus BH equal to KH or HK. At this stage, if you divide each term by KH, so divide each term by KH, so we get AK upon KH plus BH upon KH equal to KH upon KH. Here KK get cancelled, here HH get cancelled, and here both HK get cancelled. So remains A upon H plus B upon K and is equal to 1. That is nothing but this. A upon H plus B upon K equal to 1. So this is the result that we want here. So in this lecture we have solved 10 examples based on intercepts, inclination, slope and acute angle between two lines.